Morning, students. Now, this class, we are going to be continuing again the tree concept. In the tree, we are discussing in the last class binary tree. So, we have now completely clear about the binary tree, and we have discussed also what is the difference between tree and the binary trees. Binary tree means it should have at least two children. It should not have more than two children. Every level it has to be a two children like that. So but binary tree is so ordinary tree is not like the. These are all the things, some basic concepts which we have discussed. Today we are going to be discuss about the continuation of the binary tree only. In the binary tree, how it is going to be represented in the memory. Okay, so like in the pictorial representation we can tell it as like a tree will be defined like this and graphical representation and all. But in the memory, how you can define it? There are two popular techniques, methods we are following. One is a sequential or a linear representation. The next one is a linked list representation. Okay, sequential or linear representation will be always represented in the terms of arrays. We know already. We have studied the arrays concept. Array is a it's like a basic thing which we have studied. This it stores all the similar data types, and this very simple method of the memory storage. Okay, this in this tree also sequential representation means it always will be taken into the array concept. Okay, so in the sequential representations, nodes are accessible sequentially. Okay, it should be in the sequential order. This representations always requires a numbering of nodes, starting with the nodes on level 0, and then you can make it as a level 1 and so on. Already I taught you how to make it the level 0, level 1, and level 2 on the previous classes. Okay, so we have to make it like a sequentially. Nodes are numbered from left to right. That's very important. These nodes are maintained in a one-dimensional arrays always. Okay. For example, in this, consider this is a binary tree. It's a very simple binary tree because A is a root node and it has a two children complete B and C. A root node is numbered as 1, then its left child is numbered as 2, and the right child is numbered as 3. A is the parent and B and C are the children of this particular A node. Okay. The above binary tree can be represented using an arrays like this. Okay, how it has been. Suppose, for example, A of 3 means I'm taking A is the array name and how many locations. This is the totally three locations, three spaces are going to, because it's a continuously, commonly it is having a 3. The length of this is the 3. Okay, I mean total nodes or 3 nodes. Okay, so that's why 3 is a size. A of 0 is A because it is a level 0 node, and A of 1 and A of 2, B and C. Okay, next nodes. So it is allocating in the 1, 2, 3 correspondingly. In level 0, maximum number of node is 1, and in level 1, the maximum number of node is 2. This is the general thing of the binary tree, because binary tree always root node, that root node should create a 2 children. That is what the level 2 node means. Sorry, the level 1 maximum number of nodes is always the 2 only. Therefore, we used array of maximum size is a 3 here. Okay, 1 plus 2. Similarly, this is another example, like a many more nodes are there. A is a root node. It has a like complete binary tree, like a B and C. Again, B is having a binary tree, D and E, and D is having a binary tree, and E is having a binary tree. And similarly here, the above tree, note that left child of C is empty. See here, that this is very empty node, and its left child and the right child are also empty, which will be at indices of 12 and 13. Finally, left and right child of F is also empty, which will be indices 14 and 15. See, these are no like dotted lines, or it does not have the no actual nodes. It is like a, if it is there, it should be taken. Okay, in the above binary tree, number of nodes are 15. We require actually an array size is 15. The array representation is shown as like this. Okay, if it is not there also, you have to consider it is placed. You have to take it this. So then you have to make it as a array size. Okay. Uh, so sometimes what we make a mistakes we will be seeing. So only available things we will be taking as, but we are in the binarity. We are not supposed to do that. You assume that this is available here. Okay. Then you take it, and wherever it is not, this node has not been created, that should be presented as a null or a like a without any values. Okay, see here, this is what we have done it here. So total number of nodes are 15. So a of 0 means the first level 0 is a node, then it is represented as 1, and level 1 b and c, that is a1 and a2. So 2 and 3 the nodes are. Then a3 is, what is the third level is d and e. And in this, F only is present, one particular node is not present, then you can put it as a have, means null. Okay. Similarly, you create all this for the all the nodes, which is now till the 15 nodes has to be ended. So total number of sizes. Okay. So representation of the binary trees, and also how to make it like a in the formula. Some formulas we are going to be use it here. Okay, we can identify the father, the left child, and the right child of an arbitrary node. How to identify? So sometimes, if you are writing in the arrays concept, how if it in the pictorial representation, you can easily identify. Suppose if I am writing in the arrays concept, how to identify it? So for this, we are going to apply some mathematical logic things. Okay, like how to following this, some procedures we have to follow it. Let k be the index of the node. You have to make it either k or I or j, whatever it might be. So you have to take some index value, that is I'm taking here k is the index. Then the further of kth index is n, always represents n into n minus, sorry, n minus 1 divided by 2. Sorry, repeat it again. The further of kth index is equal to n minus 1 divided by 2. So the number of nodes minus 1 divided by 2, that is the kth index. Okay, the left child of the kth index is 2 into k. Okay, these are all some procedures we need to follow. Right child, how we can mention it? 2 into k plus 1, we can take it. For example, father of 7. Okay, okay, in the example, father 7. What is a 7? F is a 7. Okay, F is a 7. Father 7, like a seventh node, 7 minus 1 divided by 2, 6 minus 2 is equal to 3. That left child is 2 into 4 is equal to 3. See, we are getting here, the father is in, what is it? F is in which level? We got it here. F is in 1, 2, 3, third level. Okay, this is answer correct. Third level, we are getting. Left child is, how many left child are there? 2 into 4 is equal to 8. And right child is 2 into 5, because 2 into k plus 1, 2 into 5 plus 1 is equal to 10 plus 1, 11. See here, this is, yeah, how can you put it in this? Okay. So this is the formula which we have to follow. The above example, it is understood that the father's seventh index is third index, the left child of fourth index is eighth index, and the right child of the fifth index is 11th index. See here, in the picture we can tell it. What is it? For the say, F is a seventh index, we have seen. The right child is, what is it? What we have got it here? 11. 8 and 11. Okay, left child is 8. Yeah, what is the 8 is here? G. Left child is obviously 8. And what is the right child is? Right child is 11. Okay, so this is what we have got it. So we have to follow the same procedure. We are not supposed to. These formulas should be remembered. Okay, you have to remember in these formulas. These are all very important formulas. Okay, so next one is representation of the binary trees. continuations. In the binary trees, we can make it as a two things like a one is a left skewed tree and right skewed tree. How we can derive it? The tree is called a left skewed tree means there is a only left subtree is available. If the only the left subtree is available in this tree, then it is called a left skewed tree. If it is only the right subtree is available or present, then it is called a right skewed tree. How we can mention this is in the arrays concept. The nodes are numbered according to the binary tree. The number of nodes in a full binary tree can be taken into the size. See, you have to assume this is A and again C might be, and this is like that. So totally 1, 2, 3 already. So another 3 has to be present here. Here, C. Then C can be binary tree means C can be taken and again B can be taken, then 6 things will be available here. So total we have to take whichever is present you put it, whichever is not present you make it as a null. Okay. So the above representations, we have a left skewed tree A, B, C only, and then number of nodes which is like A of 6, so A of 7. Totally 7 is the size of the array in a full binary tree. The level is 3. We are taking A, B, C, 3 levels, and 2 to the power 3 minus 1 is equal to 7. We require an array of size of 7, even though there are only 3 nodes. Even if it is a 3 nodes are available, already I told you, you should have to take it as a what is that? The full, you assume that this is like a complete tree, binary tree. Okay, so take it this, and the above representation is a wastage of more memory, definitely. So because whichever is not present, also we have to mention it here, like it is a fixed size, we have to take it in the memory. Okay. So advantages of the sequential representation. What all the advantages are available in the sequential representation? This representation is very easy to understand. This is the best representation for complete and full binary tree representation. And also, if you are using this sequential method, means array concepts means definitely it will be the programming of this particular tree is very easy. Okay, it is very easy to move from child to its parent and vice versa. Means parent to child and child to parent. It's helpful for the insertion and deletion. And another two operations we are going to be discussing the previous, in the next class. So these two operations are very easy in the sequential representation. Usually, this is very easy to understand. There is no like complicated methods because arrays is a very easy concept already we have studied, and also it is make it in a sequential representation, so there is no confusion in this arrays also. But only thing is, what all the some disadvantages are available. Lot of memory area is wasted. Why? Because already which we have discussed, like if even if it is not present, left side or right side, whatever it is not present, we should have to assume it and create it that particular memory. So that's why memory wastage is more here. Insertion and deletion of nodes needs lot of data movement. So when you are doing the operations of insertion and deletions, the movement from left to right or right to left means more, what we can take it as no, like a sequential means more things. It is not going to be achieved immediately the results. Okay, execution automatically. If it is taking data movement more means, then execution time is also high. Okay, this is not suited for trees other than the full and complete tree. When the tree is completely binary tree or full binary tree means, then it will be very easy because all are present. So how many memory spaces we are creating, that many memory spaces only will be taken. But if it is not a fully binary tree, then the node which is not available, so that also has been created here, but it's not utilized. Then it is automatically it's wasting the we are wasting the memory there. Okay, these are all some disadvantages. Next, we are going to be see about the another representation of the binary tree. Another technique of the binary tree representation is linked list representations. This concept also already we have discussed in the linked list concept, the same thing we are going to be taken into uh, taken into this tree concept. Linked list representation is the most popular way to present a binary tree. So comparatively the arrays, we are making the binary tree representation with the help of linked list. So we know very well linked list means we usually get it like a three parts. One is the information field, and then one is a left link and right link. Means pointers, the concepts we are using always in the linked list. Information field is already we know that that is a node, which node is or which element is present. That is which element is stored there. That is information. Left link is always tell the field which contains the address of the left node. And right links always represent what is the address of the right node. Like this is the three fields we are having in this. See here, left link, information, right link. Okay, and representation of the binary trees, how we can make it is in a linked list. Okay, take it this as an example. A, B, C, and D. How many nodes are present? 1, 2, 3, 4, 5, 6, 7 nodes are present. And linked list representation, if you are giving, you take it like this. Okay, take it like a tree representation only. Take it like a tree, like A is starting node, that is a root node, and there two fields are adding here. One is a left link, another one is a left right link. See here, this is a left link and another one is a right link. So left link again it's creating another node, that is a B node, and again it is having the right and left. If it is having see here D, then it is furtherly again it's creating a node, means then it is has to be go to the next one. If it is not creating, we have to put it as a null address. Okay, and here the leaf nodes automatically will have a null address because it's not going to be create any nodes. Similarly, it has to be created like this. Okay. So what are the advantages of the linked list representation? This representation is the efficient use of computer storage and computer time. Majorly, it saves the storage and time. The insertion and deletion operation performed more easily because it's not going to be repeated. Sequential. In the sequential, we used to make it so much of time. It means insertion and deletion if you wanted to do starting from that. But end it will be taking many repetitions. But here it is not like that because we are taking the address here. So then if it is address is present, then easily we can identify where the location, where it has to be presented, where it has to be deleted. Okay, so that's why the insertion and deletion operations performed more easily. The insertion operation is straightforward way, and deletion operation is performed by using the pointer change. Okay, usually insertion will be a simple one, but in the deletion, if it is coming, we have to mention the pointers. Point means address. Okay, the size of tree structure is unpredictable here. The linked list location is suitable technique because it allocates a memory space dynamically. There, what we have done in arrays, we have, if it is not present also, we have been created like a permanently, means fixed memory size we have been created. But here it is not like that. We can make it as a dynamic representation because unpredictable. It is not a predictable one. Okay, this is advantage, and this is some linked list. How to create a binary trees using the linked list. This is algorithm. If you go through this, what we have studied, the same thing only available. There is a pointer is not equal to null, then it has to be stored. Then if it is, like if you wanted to create a child, then create a new node, and you have to make it as a new left node and create a tree in the left side. Else you have to create a null, means if it is a leaf node you have to create a null. So then if you want to create a right child, repeat the same process, and if right node has been created, then you stop this, and these steps should be repeated until and unless it reaches the leaf node. So this is the algorithm, simple algorithm of like a binary tree using linked list representation. Students, thank you so much. Based on this algorithm only, you have to make it a program. This is very important concept. Uh, So please go through this algorithms, and next class we are going to be discuss about the binary tree operations. What are the binary tree operations? Okay, now thank you so much.